Hi everyone, welcome back from the break. We are going to be talking about how people apply regression in practice. So we're going to be actually using Python, which is a computer programming language, to analyze a series of data points and find the best fit linear regression line, as well as plot out these points. Now, many of you all have said that you do not actually have very much experience with Python. Many of you have almost never used it. And so I'm going to first start by giving a gentle introduction to the basics of using Python and using Jupyter Notebooks. And let's see, let's switch over to Chrome. So this here is an example of a Jupyter Notebook, which I have decided, which I'm using Colab to do. So let's go ahead and type out, let me delete this thing here, and let's type out an introduction. So it's often useful to document stuff, and so if you create a text block here, I might say something like introduction. In this Python notebook, we are going to learn about regression analysis using scikit-learn package. Using the scikit-learn package. You may follow along using either Google Colab. So let's let me get the address, or Toronto syzygy. So using either of these, and you should create a new Python 3 notebook. So the way you do it is, this is the default in Google Colab. So if you just go to New, a file, and create a new notebook, that will by default give you a Python 3 notebook. Or if you're using syzygy, so that's here, once you log in, you'll see a menu like this. You'll go to New, and you'll click on Python 3, and that'll give you a notebook that looks like this. So here we're in the University of Toronto syzygy server, and you can do everything I'm going to say in either one of these two interfaces. I'm going to use the Google Colab since it has a couple nice convenience features, but either is fine. Note that this notebook will be available after class to download. So you don't need to worry about typing everything I type down, and this will be available after class. Okay, so let's start with some basics. So let's create a new cell. Let's see. Oh yeah, some people are just talking in chat about using Python for research, and this is part of the reason I'm introducing this to you, because Python is one of the workhorses of data science and like computational biology. And so if you're ever going to have to do an analysis on data, Python is one of the major options. The other ones are things like R. People used to use SPSS a lot, though I haven't heard as much about that lately. MATLAB, and there are yeah, so there are a number of different choices, but it is no longer a choice for you all in this class because I'm making you do it. And your quiz 3 will involve a Python component, by which I mean I won't expect you to do anything new, but I will expect you to analyze a data set that I'm going to give you. And so you will have to analyze it somehow. I won't, and I am requiring that you use Python to do it, even though in practice there are a couple different options. But I will be giving you some code to do it. So now Python basics. So there are two types of blocks in a Jupyter Notebook. There are code blocks, and there are text blocks, also called markdown blocks. So we are currently in a text block, which you can mostly type in normally as text, including writing math. So things like f of x is equal to x squared plus 1, you just need to put it inside dollar signs. Okay, and another thing you can do is you can type, once you're done, you can type Shift-Enter to finish a text block and go to the next block, or just click outside. You can also double-click to get back into edit mode. Okay, so if I click outside, I'm gone. I can double-click to go back in. It's slightly different in the ones on the University of Toronto syzygy server. So there you need to manually select Markdown instead of code. So if you change this to a Markdown block, then you can type stuff there. And then you'll need to type something like Shift-Enter, and then you'll get the text block to work properly. Okay, so now let's go back to this one here. So these are the very basics. So that is a text block. And the other type of block here is a code block. So you need to create a new block. So you can use this button here, or you can press the little pop-up here, or in the University of Toronto server, you just hit this plus sign here. And you create a new block, and it'll by default be a code block, and you can switch it to a markdown block if you want to like type text instead. So now we're in a code block, and we are now in a code block. Things you type in a code block are interpreted as Python commands, unless you start with a number sign, which signals that it is a text comment. So you can have text comments in a code block, but of course they don't look. You don't nicely format them. They're just text, and they're a command saying ignore this. Okay, so now let's turn you all into Python programmers. So open up your Python notebook and type in print hello world. This is of course the standard thing. And then the next thing you'll do is you'll need to type Control-Enter or Command-Enter. Oh, sorry, Control-Enter, or I think it's Command-Enter on Mac to run the command block. Alternatively, you can press the Run button. So there's a Run button right here. If you press this, well, it'll take a moment to connect to a server, and then hello world, you are now a Python programmer. The other thing you can do is I often use Control-Enter, so if you see me not clicking and things running, that's because I'm doing that. There are a couple other options. This is to the left on Google Colab or on top on Syzygy. So if you're over here in Syzygy, you might have x plus 1, print x plus, actually let's do hello world. If you're doing print hello world, the run button is up here. Or you can press Control-Enter and it'll do the same thing. Okay, any basic questions? This is all just formatting so far. We've done nothing super fancy, but hello world is the classic initial first program. So if you've written a program that prints hello world, you're now a Python programmer. Okay, but now let's do something a little bit more non-trivial. Okay, so now we're going to talk about variables. So setting a variable. Anything that starts, almost anything, but almost anything that starts any word that starts with a letter can be a variable, like x, or like y, or like x1, or like y200, y some random string of characters, s, whatever. So any of these can be variables, and we're going to set a variable x is equal to 5. And then we're going to print a variable. We're going to print x, and Control-Enter, and 5. We just printed the variable 5. And we can create another code block and continue doing stuff like this. And note that anything you've run so far, so we just ran x is equal to 5. Even if you're in another code block, the same variables are set. So your session is persistent. So you can still print x and you get 5 again. You can print the other stuff like x times x. So that's using the asterisk symbol. You get 5, 25. Let's say y is equal to 4. You can also print y. So 5, 24, y. We can set y equal to y plus 1. So note that this is one of the differences between using a programming language and doing math. Because saying y is equal to y plus 1, that doesn't make any sense at all mathematically. What this means here is we're taking the old value of y, adding 1 to it, and then we get the new value, which is 5. So here, if we do print y, you'll get 5 instead. You can also print text with this, with numbers. So y is equal to y, and that gives you y is equal to 5. Okay, let's see. Let us try it out and make sure you guys are on the same page and you're not completely lost. So note that we can do simple addition and subtraction. So now I'm going to go back to my PowerPoint, and I'm going to ask you to tell me the answer to. So I'm going to ask you to basically run all these commands and tell me what answer you get out of this. And let's reset the, yeah, okay. So you need to create a code block, and you need to run all these commands and see what happens. If people are lost, you should let me know. Otherwise, I'll assume you're just slowly going through and typing in each of these things. Okay, great. So it looks like we're starting to get our replies. So we have some questions. We have a lot of C's, though. Okay, so let's see. So C there was 58.36. Let's see if that's correct. So let's create another code block down here. So we just created another code block, and we have x is equal to 123, y is equal to 234, z is equal to 345, and we're going to print x divided by y times z minus x. And yes, it's 58.36, etc. So yes, the answer is indeed C. Okay, let's try another one. So what happens if I print this thing? So x divided by y. Let's see. So some people couldn't get print y plus 1 to work. You need to make sure that you put the so you need to make sure that when you're printing y plus 1, that you have it inside of parentheses. So you need these are functions, and so everything has to be inside parentheses, or it won't count. Let me reset this while I ask you to print out this answer. So note that it's the same thing we had earlier, but yeah, so we're starting to get some replies. And so this is what happens. We're a bunch of D's, it looks like, in chat. And well, let's see what happens when we try to do this. So let's say that we had print x divided by y times z minus x caret 2. Note that this is one of the weird things about Python. It uses the caret symbol to mean something completely different. So that is not a power symbol, and so you should be careful because it does not mean power, and it'll give you an error if you try doing that. Okay, and so this is what will happen if you do something that is not supported. It'll give you some kind of error. For example, if I do print y plus 1, it'll also give me an error because I'm missing parentheses, and so you'll need to do that. So what is power? There are a couple of different ways of doing power. I personally prefer using the numpy power, so we're going to get into this in a moment. So numpy.power5. Oh wait, did that not work? Oh, sorry, I did that wrong. Oh, it's power, not pow. Dot power. Invalid number of arguments. Just a moment. What am I doing wrong? NumPy power. Oh, you need 2 numbers to take a power. That's why. Yep, that's what I'm doing wrong. So, yeah, so if you want to take, this here is 5 times 5, or equal 5 squared. Okay, and that gets us into actually the next topic, which is how we, there are some built-in functions, and there are some functions that aren't built in. And power is a function that isn't built in, and so you need to do something called a Python import. So basically, there are these big packages of code that other people have written, which we're going to be making use of today, that give us useful functions. So we don't, by default, have a power function, but you can import a power function, and that'll allow you to take things like 5 squared. So let's see an example of this. So this is one of the other major parts of Python, which is its large library of imports. So Python imports So now let's import the Python packages that allow us to run linear regression. These are bundles of code other people have written to make your life easier. You can just copy all of the imports when you need them. Okay, so let's give an example. So you just saw an example of that, where you could import numpy as np, and this imports a bunch of numerical functions like numpy.power. Okay, and note that I can still write comments by just starting with a hash mark with a hashtag. So these are all comments. There are a couple other ones that I want to import. So I'm going to, because we're talking about linear regression today, we're going to import a linear model. So scikit-learn happens to be a big package of scientific computing functions. So import scikit-learn linear model, import linear regression. So this imports linear regression. And from scikit-learn.metrics, import mean squared error. So this imports mean squared error as a function. So now there's no way to know in advance what these are. You just need to know the particular packages you're importing. For any packages that I expect you to use, I will tell you what to import. And so, and lastly, from matplotlib, import pyplot as plt. So import plotting tools. So these are just a bunch of packages of Python code that give you functions that make your life easier. And we'll see a number of these. So let's first start by talking about numpy, which numpy is helpful because it allows us to work with vectors. So we have x is equal to np array, so numpy array, 1, 2, 3, 4, 5. And then if you print x, you get 1, 2, 3, 4, 5 as a vector. Oh, could I slow down a little? Yes, absolutely. Yeah, thanks for, yeah. So basically, let me just repeat everything again then. So basically, we have these big bundles of code that people have written to make life easier. They're called Python packages. And when we do these things called imports, what you're saying is, I want to use all of this code that other people have written because they wrote a bunch of algorithms and functions that make my life easier. One example of this is, say, numpy.power 5, 2. If I print this, that gives me the 5 squared, because the powers aren't something that are a default in Python. But you can use these packages to get you these fancier functions, or like numpy.sine of 5. So sine, cosine, tangent, powers, these fancier functions that aren't defaults in Python. You import these packages and then they give you these useful functions. But here, what we're working on is the, oh, sorry, let me not delete that. What we're working on is these arrays. Oh, there was a comment in chat. I don't quite understand the comment, but so if you can, yeah. So please rephrase your question if you had one, Ryan. Okay, but yeah, so we have all these different functions. And what you can do is, these functions are nice because you can do stuff with them. So for example, if you have another array, y is equal to np array 5, 4, 3, 2, 1, you can print x plus y as vectors, and then you get 6, 6, 6, 6, 6. 6, 6, 6, 6, 6, 6, 6, 6. Yeah, that's right. 5 of them. And there are a couple other things you can do with them. For example, you could also print the 2 times this vector. So that gives you 2, 4, 6, 8, 10. And so you can do math on vectors. You have to be a little bit careful, though. So be careful because Python numpy does not do things using standard matrix rules. And there are reasons why the computer programmers decided that they wanted to do this, but they do not match the rules that we exactly match the rules. Oh, yeah, I'm going too fast, aren't I? So, let me start. Let me finish this thought, and then I'll go back a moment. So the thought you have to be a little careful, because if you print x, you have 1, 2, 3, 4, 5 here. But if you print x plus 1, so normally you can't actually add a matrix, a vector and a number. But Python lets you do it by just adding it to all the numbers. So you get 2, 3, 4, 5, 6. This is different from the behavior that you should learn in math class because the computer scientists have a slightly different understanding of vectors. So just be a little bit careful whenever you're doing this and make sure everything works out. Let's go back now. There was a question about mp.sign. What does that mean? So suppose I want to know cosine of 15. Okay? Unfortunately, cosine of 15 is not a function. Cosine is not defined. Right? So luckily, however, I imported this numpy package here. And so what that gives us is it gives us some functions. So if instead I do mp.cosine, that gives us the cosine function. Because someone else, the people who wrote numpy, decided that cosine was a really useful function and that really we don't want to have to rederive cosine. We just want to have that available. And so cosine of 15, that just gives you, well, the value, mp.cos gives you the value of cosine. mp.sine does the same thing for sine. mp.tangent gives you the same thing for tangent. Or like mp.square root gives you the square root of it instead. So basically, these are just all the commands that people have written to make life easier for you as a mathematician, because Python by default doesn't have things like square roots. Okay, am I all right to go a little bit further? So I'm going to ask you to try something out now, because it's good to keep everyone on the same page. So let's say we had x is equal to mp.array of 1, 2, 3, 4, 5. So what we had before. Let's say y is equal to x. So we're setting the array equal to itself. And let's print x times y. And I want, can you clarify the arrays again? So arrays are vectors, basically. So you should think of arrays as vectors. Arrays are what NumPy calls vectors, almost. So they're almost like vectors. They're not quite the same thing. They're a computer science concept that almost maps onto vectors, but not quite. And we're going to treat them like vectors for the most part. They're just collections of numbers, lists of numbers. Okay, so I'm going to ask you what the value list is, and let's go back into my PowerPoint where I'm going to ask you to try it out. So which of these values is it? Let me reset before anyone replies. So import so you need to import numpy as np. You're setting an np array, and you're printing out x times y. Okay, yeah, so you'll notice that we have a lot of answers which are B. So the actual answer here is, let me write that down on here. So the actual answer is B. Even though, so basically what we did there is we took each of the individual entries, 1, 2, 3, 4, 5, and we multiplied them component-wise. This is not vector multiplication. So arrays are similar to, but not quite, vectors in mathematics. So you should be a little bit careful because the operations that NumPy does are slightly different from the ones that you probably assume as a mathematician or as a biologist taking a math class. So you should just be a little bit careful about that, and this is my way of pointing out that things don't always, you should test things before assuming that something does what you think it does. Let me switch back over to my Python notebook. Okay, are we all on the same page? Okay, so let me run this, and that gives you 1, 4, 9, 16, 25. Okay, so now you guys have the basics of how you can use basically Python as a calculator. Right now, all we've taught you how to do is basically how to add, subtract, etc. So you can use it as a calculator, but you can do a lot more with it. So now I'm going to actually start on linear regression. So the first thing we need to do is we need to define the data points. So we're going to have two different arrays, and so we're going to have the t array corresponds to time and is the independent variable. It's the independent variable because it's the variable that you use f is a function of t. So let me do this in code. So here we have p is equal to mp.array 1, 2, 3, 4, 5, 6. So there is a, let me just do lat first, print p. So this is a array that corresponds to time. For a complicated reason, we actually need to turn this into a column matrix. And so I'm going to give you this magic invocation, which turns it into a column vector instead. Turn into column. You can mostly ignore that, but it turns out that the library we're using expects a column vector instead of a row vector for the independent variables. But so we have an independent variable, and we can also create another array and say the h array corresponds to height of the willow tree, and is a dependent variable because it depends on t. So note that this is for a function h of t is function h of t is equal to something. It's going to end up being mt plus b later, where m and b are parameters. So we have some function, and we're going to have h of t is going to be mt plus b, and note that we had to reshape the time array to a column, and you can just copy the magic invocation dot reshape -1, 1. Okay, so we have an h array now, so we're going to have h is going to be equal to mp.array 404, 407, 412, 417, 420, and 424 for the inches tall that the willow tree was at any point in during any of the months. So the 404 corresponds to the height at time 1 in January. The 407 corresponds to the height in February. The 412 corresponds to the height in March, and so on. Okay, so all I'm doing is I'm putting data into Python now. So like these are the data points we had last time, and now we have the data in a format that Python can understand. So now, well, one of the first things you should do as someone who's working with data is you should look at it, because that often tells you something. So let's go ahead and look at it. And the way we'll do this is we'll use something called a scatter plot. Let's see what the points look like. Okay, so if we do a scatter plot, now here I'm going to be using the function plot, plt, that I imported earlier. Because this is basically a function that allows you to draw nice visual graphs. So I'm going to do plot, and I'm going to use a scatter plot type, th. Oh, what just happened? Oh, did I forget to import all my imports? Oh, I forgot to import my imports. So sometimes, if you forget to hit the run button, you won't have actually imported the stuff, and things won't work. But now, okay. So now if you do plot.scatter, you end up with the scatter plot. Note that you could also do plot.plot, in which case you get a line instead. But let's show it as a scatter plot because it's a little bit more visible. And of course, as a good data scientist, you should always put labels on things. So let's add some labels. So plot.x label is going to be month of the year. Plot.y label is going to be willow tree height in inches. And I'm going to do a plot.show just so that it show. Oh, wait, what happened? I mismatched my quotes. Okay, so what we're doing is we're plotting all the data. So this is all the data that we had up here. So for each of our data points, 4041, we plot that on the scatter plot, plot t and h. So this is all the things on the x-axis, and this is all things on the y-axis, the horizontal and the vertical axes. Okay, and so that was because we plotted these couple points. So I'm going to now ask you to do something similar. And so let's try out a scatter plot of some random points. So there are ways of getting random points. I'm going to just do this now, and so you can just copy this down. So you're basically getting 1,000 normally distributed random points. And then we can plot it on a scatter plot like we did before. And I'm going to switch the axes to be square, just because that'll make life a little bit easier. And what does this look like? So try this out, and then you can tell me what that looks like. And let me switch over into my PowerPoint, which also has the code available here. And so now I want you to tell me what this looks like. Which of these, A, B, C, or D? And let me reset. Okay, it looks like we're starting to get some replies in. People seem to think it looks like C. That is correct, in fact. So, let me switch back over, and it looks like people have gotten it into my Colab. And if I run this, what you'll see is that, yes, it's normally distributed. I picked, so this is Gaussian random points, and this is also more Gaussian random points. And so you end up with this vaguely symmetric circular-like shape, but with some amount of randomness. In fact, the other plots I had were things like 2 times xrand, which gives you lat shape, or 2 times yrand, which gives you lat shape, or xrand times yrand, which gives you this weird butterfly shape. But but the original one was actually just this vaguely symmetrical-looking shape. Okay. So that's Python. You are now Python experts. And now we can use all your Python knowledge to fit a linear model. So let's go ahead and type this out. So this is the point of today's lecture, or this half of the lecture, fitting a linear model. So what we want to find a function f of t is equal to mt plus b, where t is time and m and b are parameters that has the least mean squared error. And the way we're going to do this is we're going to use the linear regression thing that we imported from scikit-learn. So let's call our model. We're going to say model linear is going to, the type of the model is going to be linear regression. So this is built into scikit-learn. Oh, you miscopied down the import plot. So that was up here. Let me just copy all. So this was this import here. So you should copy down all 4 of these imports. Let me drop them in chat, actually, so that you can just copy and paste them in. So you should be able to just copy and paste in the chat I just dropped in, and run that in the code block, because these are all the imports you need for today's lecture, or most of them at least. Okay? So this is built into scikit-learn. This is a model linear regression. And what we can do is, you know, we did a ton of like derivatives, and we did a ton of like partial derivatives, and then solving systems of equations in order to find the minimum, right? Well, luckily, someone has put all of that in the code for you. So if you just fit these 2 variables, this command does all the tedious computation for you. So magic. Now we fit that, well, we can actually go look at the various variables. So let's look at it in code. So the slope is going to be equal. So first, let's print out the model.coefficients. So this is going to be the slope. So let's say slope is equal to this. Instead of printing it, I'm just going to do this. And note that I'm going to put a 0 here. We have to specify 0 because although our system has only one independent variable, time t, the model allows multiple independent variables. So we have our slope, and we can print our slope. So print slope, slope. Okay, so that's the slope of our line, and this is with the line we had earlier, 4.11. And we can also get the intercept. So intercept is equal to model.intercept underscore. So get the parameter b. And so we can print the intercept, and you get that. And if you want to be fancy, so I don't expect you to be able to do this yet, but you can even like print out, say something like function is f of t is equal to a blank t plus blank dot format round slope to intercept. Don't worry about this line. But that just allows you to say something nice like function is f of t is equal to 4.11t plus 3.996. Okay, and now we have the parameters, so we know what the slope is and we know what the intercept are. We can plot this on the same figure. So let's go ahead and give a little bit more text to describe what we're doing. So what we're doing is we're plotting best fit line. Let's plot the best fit line on the same figure. So note that we can either directly use the equation we found, or it turns out that the model gives us a function to automatically give us the equation, model.predict, to get the predicted values from the best fit line. And when we do this, what we're going to find is, well, let's start with our scatter plot. So that's our scatter plot, right? And the next thing we're going to do is we're going to plot t.scatter t and then t times slope plus intercept, because that is mx plus mt plus b, right? And I'm going to make this color red, but it doesn't really matter what color you use. Sorry, it allows a scatter plot. I want this to be a line, so let's just use the plot symbol. And so now all of a sudden, can you guys see that? Yes, you can. So now all of a sudden we have the best fit line as well as all the different data points on the same plot. Now, of course, we should always put labels. So x label is month of the year. Plot y label is willow tree height in inches. And one other thing I should mention, and this will make life slightly easier, instead of actually writing out tx plus mx plus b, you can also just do model.fit. So you can also, instead of doing that, you can plot t and model.predict t, color, let's say purple. Oh, is purple not a valid color? What happened there? T model.predict t color equals green. Something went wrong, and I need to figure out what it is. Color red, invalid syntax. Oh, I forgot the equal sign. So whenever you have a typo, everything's going to go wrong. So you can plot the same thing using model.predict. And so these are both ways of drawing the line for the having a lot of trouble importing those. Importing. Okay, that's a little bit unfortunate. Let me wait. Is that not working in here? Okay. Huh. So it's working for me when I copy paste them. Are you doing this in? Let's troubleshoot a little bit after class. But these imports do work for me. When you have a chance, post the error message that you get in the chat, and I'll take a look at it there. But for now, let's go ahead with the scatter plots. And so now we have the plot, and we can plot the best fit line on the same figure. And let's make it red. I think that's a nice color for that. And now I'm going to ask you guys to do fit to a model. So let's go back to the PowerPoint. So suppose we have a student, Alice, who has taken the first 4 quizzes of MATA35 with marks of 52, 63, 68, and 74 on quizzes 1, 2, 3, and 4 respectively. Alice wants to use a linear regression model to predict her score in quiz 5. What does she predict to be her mark? And if you're having technical difficulties while people are trying to figure this out, you can drop them in chat and I'll try to troubleshoot them. Actually, maybe I skipped a couple steps, but anyway, this will be the try it out in a moment, and I'm going. But let me give you a couple more tools before we actually try this out, since I think I skipped ahead a step. So let's go back to the Colab, but just keep in mind that that's what we'll be doing in a moment. So we just plotted the best fit line, and we haven't actually talked about how much error, right? So another thing we can do is we can also compute the amount of error of our model. So root mean square, just mean square error. And that's going to be something easy. So we're going to print mean squared error. And that's just going to be the function we imported called mean squared error h and the model predict of t. Because we're comparing the original the actual data points h to our predictions from a model after we use them on each of our data points. But now, of course, we can also use this model to predict new points. So let's see, prediction of new values. So what is the predicted height of the willow tree in July? Well, if we print the, let's say, July prediction, that's going to be model.predict of 7. And note the double brackets. That's just a fact that the model expects the data in a particular format. And when we do this, we get our prediction of 428.4 for the height of the willow tree in July. Note that you can also do this for multiple months. So I'm just going to copy and paste all this. And instead of just having the 7 there, I'm going to have a 7, an 8, and a 9. So this gives us our predictions for multiple months. Prediction 7, 8, 9. So you have these values there. And of course, let's say we could have a December prediction, which is going to be model predict, well, it's going to be December is the 12th month, so that's going to be a 12 there. So you'll predict that's 448 inches tall by December. Okay, so now you finally have all the pieces that we need for the example I was giving a moment ago. So let me just write it out a little bit for you in here to try it out for this quiz score example. So suppose Alice is taking MATA35 and has taken the first 4 quizzes with marks of 52, 63, 68, and 74 on quizzes 1, 2, 3, 4, respectively. Alice decides to use linear regression to predict her score on quiz 5. What does she predict to be her mark? Okay, so now of course the first thing you need to do is you need to set your arrays. X is equal to MP array 1, 2, 3, 4, And we have this magic invocation of reshape, -1, 1, and y is equal to empty array of the scores, 52, 63, 68, and 74. And the next thing we're going to do is we're going to do a linear regression model again. So model is equal to linear regression. And model.fit x, y. Oh, I typed in a lowercase y, not a capital Y. And from that, you should be able to predict the value for quiz 5. So let's go ahead and do that. And let me switch back to the PowerPoint. Oh, actually, I'll leave it on here for a moment so that you guys can do that. And can copy down the code. Actually, let me copy and paste this code into chat to make life a little bit easier for y'all. And then, of course, you'll need to do the model prediction as well to guess which of these values it is. So notice that Alice has been doing better on the various quizzes, and so you probably expect her quiz 5 mark to be higher. And the question is, how much higher? It's a syntax error. Can you copy and paste the entire error in? I suspect that what might be happening is you might be using the wrong type of notebook, since you've been getting a lot of errors. Did you run the imports? So did you run import numpy as np? Oh, wait, you need to copy these in as different lines. So I think, oh, is that when you copy and paste? So if you're copying and pasting, sometimes it copies and pastes the new lines, and sometimes it doesn't. So that might be what's going on. So you need to make sure to have all the enters in between the different lines, and I think that might be what's up. Let's try it a little bit after class. Okay, but let's see. Hopefully people are still around, and what do people predict to be the quiz 5 mark? Okay, looks like we have one prediction that's in. So look at prediction of B. Okay, so it looks like some people are having trouble with Python, so we will debug that a little bit later, but it's almost the end of class now, so. Okay, since it's almost the end of class, let me go ahead and show you the code for doing the prediction again. So let's go back to Chrome. So we have this linear fit, so we fit this model, right? And what we're going to do is now we're going to do a model prediction. So we're going to print, so we're going to do model.predict of 5. And that gives you an answer of 82, if you typed in the numbers correct. And so therefore, the answer on here is actually C. Furthermore, what you can do is you can also get the model coefficients. So print the slope is going to be model coefficient 0. And you can print the intercept. Slope intercept is model.intercept. Oh, what happened? Model.intercept. Oh, model dot. So whenever you have a typo, things fail entirely. But so we also have a slope and intercept, and so that allows us to figure out what the line looks like. And when you plot it out, it actually ends up looking like this. And so What I've done there is actually a little bit more advanced. I plotted it out for an extra. I plotted the line, extended the line out for the 0.5, and so you see like what the trend of the slope is and what you expect. And I think that is a reasonable place to. Let me actually just give you a little bit more code that you can use, and so just to show you the code that I used to create that. So that's this code here. And you'll notice that I actually created a new array for times 1, 2, 3, 4, and 5, so that the prediction would go all the way to 5. But yeah, so I think that's probably where I'll end the class today. On Friday, we'll talk about more advanced regression techniques, things like polynomial regression, quadratic regression, that you can use these same sort of techniques for. The reason that we spent so much time on Python today is because it turns out that these things are really, really painful to do by hand, and so it's better to learn how to use a good numerical simulator or calculator or programming language to do it for you. And with that, I'm going to end class today. I'll stick around a little bit afterwards in case you guys had troubleshooting problems with the Python or if you guys have questions on the quiz. So thank you very much.